Hello and welcome. I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode number 82. In the last lesson, we looked at mocking for our unit testing in C#, and today we're going to continue going through that and getting our tests back working again. So this is just shortly after the previous one, so I'm picking right back up where I left off, but that's what we'll be working on today. So one thing, so adding the mocks like this and doing the verification like this, or what the better thought pattern there was the test I had originally. We tested it, we do the insert and we retrieve. That's sort of a going all the way through. It depends on how you define what your unit is, but if I'm defining it as my unit's just a leaderboard manager, then I would say this one's correct. If I'm defining it as add players my units of a method, this one's correct. And it depends on which one you want to say is what you're actually testing, is which one's correct. So the way to think about that, though, maybe this new one may be more textbook. This is what the more textbook. This is what the unit test should look like. While this one may be more what you would actually might be more likely to run into. So just my thoughts there. I would be perfectly fine seeing either of these in these tests, and I think I could put together why each of them's doing what. I'm going to do the more textbook full test here for our purposes, but that may be the more thought of the differences here. And as such, I'm not going to fix up those. I'm going to leave those alone. So we're going to have to do that in a couple of places, though. So this test fails, and it's failing for the same reasons that we haven't defined count or anything. So I'll grab these two setups here. So one thing we could do slightly differently, if we find we have a lot of setups coming at multiple times, what you can do is you can write your helper method to actually do your setup here, and you can do it like that actually. So here, this test doesn't even make sense actually. So retrieved by name. So this was testing the other functionality. So we were testing add player, and then we retrieve them by name. So I don't think that actually makes sense now. So we're going to remove that test. So that actually cuts down the code a little bit. This one on the other end does make sense. So throws when adding a duplicate player. Does it throw? Wait a minute. Yeah, it didn't even throw to begin with. That's the wrong terminology. We fixed it, but we didn't add the test. So add player returns false when adding a duplicate player. That may make more sense. So now let's grab our mocks here. Now let's not. We'll add them. This one's going to be slightly different. So another thing I did here, I used this start setup sequence. Let's see if this works. I actually don't know if this works or not, so we're gonna go on an experiment here. I'm gonna say mock dictionary dot setup dictionary dot count dot return 0 and dot return 1. So set it up at two different spots here. So I don't know if this actually works, but we'll see if it does. I would do the setup sequence normally, but we'll see. So here for triad players, so we do need to do its setup though. So we will do it'll be the same thing. Let's give it a try as well. then insert. There we go. I had to think what I was inserting here. Returns true. So I think I want a sequence here. I don't think this is what I want, but please check these and see if these work. And this is duplicate player. All right, let's see what happens with this test. Does this actually succeed or fail, and where does it fail? Failed values differ. Expected 1. Actual 0. So this count did not update probably. Is that where it failed? Line 64, yeah. Okay. Oh, and we do say 1. Wait a minute. Try that again. Failures, expected false, return true. Okay, so that actually did work. That one returned true because we said it returned true here. Interesting. So that apparently does work. We set that to false. Now we get a green test. Interesting. So instead of doing a sequence, if you didn't want to, I guess you can just set it for each test. That sort of mixes up what we're trying to do, however. That would work. So let's do it like this. So I'm going to revert this and make it actually put it up here where I want it. So our classic sections are arrange, act, and assert. So up here, our changes here except this initial verification of count pretty much made sense. So the count was what we expected at the beginning. And since we're in control of count, I don't think that actually makes we care now. Wait a minute, this sequence feels a little redundant actually. So we're controlling the counts here, so and count is just a player count. Yeah, I'm not sure that I feel the need to test that actually. So what here we're testing here is that C# connected the player count to the count correctly. Yeah, I'm not sure on that one. Maybe we have our own count tests, and maybe the count just gets dropped here actually. So let's do that, and then we don't even need that sequence. Now count's not called at all, which makes sense. Let's make sure that one still runs, but I think that's actually the better cleanup. Once again, the more textbook example. Did it succeed? It did. And now our sections are more defined. So now we have an arrange section. We do all of our setup. We have an act section. This is what we actually perform, and then we have our assert. And we say true, and then we say, okay, and this was what happened. I think I like that better. So maybe we need to add a count to do add count test. So let's make that change over here as well. So count probably doesn't, we don't actually care about here. We don't care about here, and we don't care about here. That means we don't care about it here, and we don't care about it here. So that means we just need to mark dictionary here. Set up sequence dot insert nope, it is not a sequence. So the reason it's not a sequence, we're inserting two different values here. Returns true. So the first time we do it, we're adding test player, and that seems like it should be the same thing, but they're not technically the same object. let's show that. Let's see if it actually, let's make sure it works like I think it does. So that, I'm arguing this is the correct, what this should be. See what actually happens though if we do the other one. Step sequence. So what we could do instead though is we could say insert it dot is any player, like that, and that would work. Returns true, returns false. So that one should work. So let's see if it does. We'll remove this, and we will remove this. And yeah, that one works. What if we say test player? So this one I'm less sure about. I think this should fail. I got into overwrite mode. So let's see if this works. And it actually succeeds as well. So it's doing actual equals on our test players. So is player a record? That may make sense if it's a record. Yeah. So that may actually make sense that this one works as well. I would argue this one's wrong though, and this one or this one is correct. Let's use this one since it shows that it is any feature. So here, this is our arrange section. This is our act. Oh, wait a minute. This is our act. And this is our assert. So there's a problem here. This needs to be up here. But now there's a second problem. So let's make this first result and this second result. Now we can say this is the cases. So first result was true, second result was false. Alright, and now we need to do some verifications as well, so we can come up here and grab our verifications because they're going to be the same thing. So now, this one was called times.exactly 2 times. These were called never and never. That sort of makes me want to pull out insert, make it like these and say insert was never called, we only call them contains. We're using it as it returns false though, it doesn't indicate that. So maybe this is a, here let's do a to do, maybe reconsider this design. It might be cleaner test wise to check for a duplicate value and then insert if not duplicated. So I would argue what we've got here is perfectly valid and does do this as well, but maybe it would be cleaner on the data structure wise if we have these doing the same thing, because then all these removes do the same thing. This one doesn't, but maybe at that point we could consolidate our heap tree and well, we still have to traverse. Maybe we can't. Never mind. I was thinking if we make it consolidate them, but I would still consider this because then we have player insert, heap insert, tree insert. They wouldn't return anything. They just do the insert. But I guess the logic there is a little fishy. Yeah, I'd have to consider that one a lot harder. This here keeps us from inserting, but then this one doesn't know anything about inserts. So if we look up here in max heap, its insert doesn't care if it's a duplicate or anything. Maybe it should. Yeah, we'll have to consider that, but for our purposes, this is what we've got is correct. Maybe it doesn't make the most sense though, because now we're saying inserts called twice. The other two inserts are never called, so we may consider that one. Wait a minute, that should be wrong. Wait a minute, that ran green. Yeah, wait a minute. So these, I say, are never. You insert at least one value into these, so it is times dot once. Notice you've got more to it. Most once, at least once, once. Now this one should go green. So what I had written over there on the test was wrong. It did not. I wish you could read this. So how Rider does this, I think, actually makes more sense than how Visual Studio does testing, but that might just be the one I'm used to. So expected the mock invocation to be exactly 2 times, but was once. So we're saying, okay, this was only done 1 time. So what happened there? So we added a duplicate player here. So duplicate player is a different name, so it's saying this doesn't match. So this is the perfect condition where we would want to do it dot is any player. All right, now we say, okay, we expect there's to be some player inserted twice. And in that case, we just want to say we only do 1 player for this one as well. Maybe insert was fine there. So this will work. So what we're seeing is there's many ways you could do this is what we're seeing. And I don't necessarily know which one's the best, but there, returns false when duplicated player. So that one worked. So we could do it the other way too. We could say these are the specific players we want. So I would think that's exactly the same. So I would say this is a valid. And we could do it like this as well. We could say test player here times once, and then duplicate this for duplicate player. I'd argue all these are testing all the same thing and should all be about the same validity. Yeah, that one works too. I think I like the other way better. I think I don't actually care what players, it's just there's been 2 calls of player. The other one may be a little more full expression, but I think I like this one for how I consider testing. I think this one makes sense. This one's a little trickier. So here we don't want to check the count anymore, so we're going to need to make an adjustment. The adjustment though might just be this. We'll add our range act assert. I'm adding these back because we're actually seeing why we separate them and what it means to separate them. So here, let's do mock dictionary dot setup insert. This is a good spot for it dot is any player dot returns true. We need to add parentheses here. So this is a good spot for this because we're adding 1,000 players. We don't want to add 1,000 lines in a setup. So this is a good place to say, okay, if we get a player, it is true. On the verification side, we don't want to verify this. Let's do tell you what, let's do this. Let's do list of bool results equals this. Let's do it like this. This is not how I was going to do it, but I think this makes, I think we can do this. Result.add. Right. Results.add. So add this Boolean result here. So let's do that. So now we have a sequence of true. So we'll do results dot assert dot maybe same. No. This is not what I was thinking of, but I feel like there should be one of these that works here. Maybe it just does not contain false. See, I don't feel like that's right. Let's see what happens. Interesting. So let's change that to true. Does that fail? Let's make sure it fails. Make sure this actually tests what it wants. Okay, yeah. So 4 of them failed, and they failed because of it being true. Item found in collection. Yeah. Okay. So yeah. So we can use that then. So it does not contain a false. So yeah, I actually think that I was going to say we could do something else, but I was like, I think this actually makes sense. And then we can come down here and we can say mock dictionary dot verify. Insert it dot is any player times dot exactly, and we have a count up there to use. Count. And so we can do that for mocked heap. And we can do that for mocked tree as well. And that should get us a pretty good indication here of this working. There we go. All right, so we're saying that it does not contain any falses. Here, let's do one more test. Let's make sure it does fail if we do results.add false. Just add a random false in there. Yep. Okay. Yeah. So I have not used does not contain before. So I said there's last time we talked about adding packages, I said there's multiple packages for adding mocking to unit testing. There's mock and substitute. There's others as well. There's others for asserts as well, and I've primarily used a different, not the C# assert. So this is XUnit built-in assert. So if we look here, XUnit assert. I've used other ones, so the syntax is slightly different, but does not contain seems perfect for our use case here. So there's just another one that's set up though. I'm going to move this up here in this section. So now I'm setting up the mocks, or I'm creating the mocks, setting them up, and then doing this. Alright, remove player returns null when there are no players. So that's all of our triad tests. So let's consider remove now. All right. So remove, we find a player and we remove them. So now I almost feel that we shouldn't care about this actually. Does this work? I think it should. Does it work by coincidence? What happens in find player? Yeah, it works by coincidence. So here, if we come up here, we need to do mock dictionary dot setup d dot find players, passing in whatever their ID 0 const int player ID equals 0. Player ID dot returns null. Okay. All right, what does this say? The call is ambiguous. Why is it ambiguous? Whatever that's doing is not what I want to do. I don't think I've ran into this before, so why is it saying it's ambiguous? So find player does return null, right? It does. All right, let's check. All right, I actually don't understand why this one's not working. All right, let's try this. So we'll just say player All right, let's see if that fixed it. That's a little odd behavior. All right, the test does work. So what I think is it's saying is I couldn't return null because it couldn't tell that it should be null. I was like, this is null though, so that doesn't make sense. So I'm not 100% sure on that behavior. result is null. That makes sense. Count. As with the inserts, we don't care about count in this spot. What we care about is that mock dictionary dot verify dot find player, passing in player ID times dot once. That should be enough verification there. So we got our null and we only called this call once. Good. All right, so that should be a pretty decent for that behavior. So that's this case. Find player does, yeah. I was gonna say find player does return null there, right? Yeah. So remove player returns null when the ID doesn't exist. Okay, so this is almost the exact same case, but this time the ID doesn't match. All right, so let's do this. We will add our range. We'll grab this exact same setup here. Const int second player ID equals 0. All right, so that's what we're looking for. So that's this value. So we'll need that. So we also need to do this though. We need to do mock dictionary dot setup wait a minute. Yeah. Wait a minute. This case is suspect. So this is going to be the exact same test as this one. So when there are no players. So when there are no players and when the ID doesn't exist. So from a unit testing perspective, we don't care what find players, how many players are there, as long as the ID is not found. We don't care. So in doing this, in doing our analysis here to actually do the verification, we found that this is the same test case as above. You have to do more value there. So in the terminology, you might hear business value or business logic. So this is a business logic check that doesn't matter here at our unit level. So I'm going to delete this one actually. So that was going to be the same test. So remove player returns the removed player when they exist. So again, that's the actual feature here. So remove player returns a player if they were removed. So it tells you what it removed. So here we'll do our range. All right, so we need a mock dictionary dot setup d dot find player, and we will pass in test player ID dot returns. This time we want it to return a player. And look, we've got one. Wait a minute. We want this to be player test player equals new test player ID 1. We'll do it like this. So expected, we'll keep it separate. Now we have an act. We don't need this, we don't need this, we need this. We don't need this either. Range. So we're saying it's not null and it is equivalent to expected. So the player we get out here is expected. So what else do we need? We'll do the same verification here. We called find player. Passing in test player ID. So we also called player remove. Remove player to remove. We will do test player times dot once. We will do this exact same thing for mocked heap. We'll do this exact thing for mocked tree. There we go. We may have to mock that one. We probably should mock that one actually. Expected binary heap to have something there, but it did not. All right, so we need to do this setup. So mocked dictionary dot setup dot remove test player dot returns true. So now I think we'll actually get green. We're not testing this, but again, we don't actually care. So maybe that's fine. So what this does highlight though is we are missing a case. So remove player here. So the case we're missing, what happens if if they're not in the tree and heap? Is that a case we care about? I think it's not. So here we check that they're added here. One of our other business logic things here is that if we insert them everywhere. I think we're seeing a flaw in our logic here, and I think this doesn't actually matter. And at this point, we don't actually care about this either. So I believe that's actually our situation. Doesn't change our other tests. So yeah, I believe that's our actual situation. So I believe that was a logic bug there. So because of our other business logic. So yeah, so there might be a little more cleanup we need to actually do to get this looking a little nicer. So yeah, let's keep going with our testing for now though, because that's the focus for now. Remove player causes player to not show up in ranking. Again, this is a test that I thought made sense, but if our unit here is method, I don't think it does. I think this is an integration test for a business logic later. I am going to remove this actually. So find player ID returns null. Yes, okay, I'll agree that one. So range const int player ID equals 0. Player ID act consider what happens here if our constraints on inserting everywhere or to fail. Okay, sorry. I wanted to get that in while I was thinking of it. Okay, so find player by ID returns null. So it's probably by coincidence, but I would suspect this works. So mock dictionary, and this will be the same problem we had before. Set up d.find player by player ID dot returns null. I still think that should work, but apparently it does not. So there I'm just saying I intended for this to be null. And now mock dictionary dot setup find player with that ID times once. Verify, not that. So this should be green still. Okay, so if there's not one, it doesn't find it. So there's a missing case here now. So we need to add a test. Fact public void find player by ID returns the player when ID exists. All right, so let's copy this one. We'll make our adjustments from it. So player ID 0, find player returns player test player equals new, and player ID 0, score of 1. This returns a test player. Should not be not null. There we go. Let's see. Assert dot equivalent expected end result. We'll just say test player. So we expect to get the same thing out. No, let's not. Let's do player expected equals new player ID 0, 1. So the reason I'm doing that, what that shows you is that you're getting a player that matches the structure. You're not getting the same reference back. So we're saying the structure matches there, and that just makes it a little clearer. I actually think the other one would have been fine, but I think this makes it a little clearer. So let's confirm this one works. It did. Good. All right, return player by name. Same problem as the other one. It works, but it's by coincidence. Const string player name test name equals test mock dictionary dot setup d dot find player, and we'll pass in test name dot returns null. So this one's going to fail again. So I think what I actually want to do, let's see if we can't fix it this way. Player test player equals null. Let's see if this doesn't work. Okay, that does work. So I can't pass null, but I can pass null as a value. So I bet instead of that, I bet I could do up here. Let's see if this will work. Yeah. Okay, I like that a little better, so we'll make that adjustment. Yeah, so basically it doesn't know that null is a player. So maybe correct. Little not what I was expecting. Oh, null. Is there any others of them? No, I think that was all. All right, so we are back here. So act, find player, assert, it is null. It was called once, and it was player name. No, test name. That should now be green. Let's see if it is. And it was. So this again highlights that we have a missing test case. So let's add it. Find player by name returns a player when the name is found. So here it returns test player. Test player in this case is a new ID 1, no, test name 1. We'll do player expected equals new 1, test name and 1. So this is not null, called once, and then assert dot equivalent expected result. I think that'll get us a green test. Maybe. By name player. It did go green. It's not showing their indicator here though. Still not showing your indicator, but I believe the test ran. All right, update score throws invalid operation exception when player does not exist. Okay, that's this first condition. So arrange so here it's succeeding by accident again. So find player does the exact same thing we've done up here. This line. So this is just ID this time. So player test player equals null. So now it's no longer failing by coincidence or succeeding by coincidence. This one's special, act and assert. So this time, because of how assert throws works, having to do the action here together. I guess we could pull it out to its own method. So we could do action A equals update score ID 1, and we can just call A here. I think that will work, and then we can say act and arrange. Use local function. Let's just see if it works first. Okay, it did work. All right, let's see what the local function looks like. And that one works too. Okay, we'll just leave it like that. And finally, returns the updated player score. Returns the player with score updated. So we'll have a range here again. A lot of a range. So there we do the triad player. We don't care about that in this case. Act, assert. So here we're saying it's updated in multiple places. Again, that feels more like a business logic check rather than a unit check here. So we'll cut these. All right, so let's see. So find player, it's succeeding by coincidence, failing by coincidence. Great. Okay, that's what it should do. So let's come up here. Let's grab this. All right, so there's our setup. Returns our test player. That gets us past here. Then we do the updates and we assert that the player is equal to expected. Does this just work now? And it does. Okay. So what we can do here, we can do some verifications now. So we will grab our verification up here. This one. In fact, let's add one here. So we called it ID. So that one was called once, so we can confirm this is correct. All right, it's called once here as well. It's called ID though. All right, so now we do some other work though. So we have mock tree dot verify t dot remove test player times once. Insert what do we do it up here? Expected. I don't like using expected, but I think it works in this case. And then do the same thing here for the heap. Heap. I think that gets us everywhere we want to be. In that case, it ran. So there, we don't have any different testing now, but we've thought about the testing a little more, and it's highlighted a couple spots here that I may want to consider. Is this how we really want to do it? is this as clear as it could be? Could we make it clearer? Basically, is the question. Maybe the same thing here, but we'll think about that one. So next time we'll look at actually testing these now that we can. So before we were going to have trouble testing these. Now I think we're good. There's not a logic here. This one has a little bit of logic here. There's this condition here, and then down here there's a little bit of information here about what happens, but not a lot. This one there's not really anything to test, but we'll add a test for it anyway. But that'll be the plan for next time. So that'll do it for this lesson. So this lesson, as a recap, what we've done is we took the existing unit testing and we made it more maybe textbook rather than maybe what you could run into. So I won't say it's all beneficial. Like, we did lose some value of our testing, so there is some different value here. It's the thing is that the values elsewhere. So maybe like here, to do integration test that players remain after removing one. So those tests aren't provided at that point, and I don't think they should be provided at the scope I'm testing at. So what I'm saying is that it should be pulled up to an integration level. And I'll think more about that. This may still be a unit test, and it's just I've got the scope too low, but we'll come back to that and we'll think about it a little more and see what we come up with. But I think for now this is where I want to stop for the day. Again, splitting this out highlighted some questions about our design. So like here, insert's completely different here for insert in this, but we just still don't, we are not checking on these internally. Maybe we should be. Same thing here, remove. Two removes are different, and we don't actually care about these. We're checking ahead of time. Maybe remove should just be, okay, remove it, and if it removes, good. If not, we're, oh well. Maybe this one should return true or false too. Maybe that's the better way, but there's some questions there in our design, and we may need to address them. And doing the testing like this showed us them, while the other way, we just made the test work. So maybe there's some benefit from being a little more textbook. And that I will mention that is what I have seen in the past as well, is we have tests that work, but then if we try to actually clean them up and make them follow the pattern, it's like, this is hard to test. And then we get to looking in why is it hard to test, and it's like, this design seems a little questionable. Maybe we should adjust it, and then we adjust it, and then it becomes easy to test. So one thing to keep in mind there, and maybe that's a good example here of actually doing this testing right. Maybe this is a good example of why, but we'll go ahead and call it with this one. Once again, there are many ways you could test this. I'm not saying that their original was wrong. I would say it covered the conditions, and I would be perfectly satisfied to read that. I would say this one probably is covering them about the same, but we have cut out some conditions that we should add back. But for purposes now, I think this is a good stopping point. So we'll call it. So thanks for watching, and have a wonderful rest of your day.